Solving the networks, we use some applications, we use some methods and techniques. These two techniques are called universal techniques. Those are applicable for all lumped circuits. Those are mesh analysis and nodal analysis. In mesh analysis, we apply KVL plus Ohm's law. In nodal analysis, we apply KCL plus Ohm's law. The main advantage of this method is, these two methods is to know each and every branch voltage, current and power for any lumped network. That too, very most one drawback will be there here. These two techniques will fail in some networks. In which networks are, if the network consists more than two or more than two sources, with those two sources are having different frequencies, then these two techniques will fail. You see here in the network, if all the sources are DC sources, maybe current sources or voltage sources, mesh analysis and nodal analysis are applicable. Why? Because for DC, pure DC frequency is 0. We discussed already, the frequency is nothing but what? Number of cycles per second. If you take DC supply characteristics, cycle you won't get at any time. That's why you can say number of cycles are 0. If number of cycles are 0 at any time is, then frequency is equal to 0. That's why frequency is 0 for DC networks. Hence, for DC network, mesh and nodal will apply for each and every problem. Now, how to apply mesh analysis? What are the instructions we have to follow? That was given here. For universal steps are there to solve any network or any problem by using mesh analysis. Those steps are: step 1, identify the number of meshes. Identify the number of meshes. What is a mesh here? Mesh means nothing but it's a loop which doesn't contains any other loops within it, is called mesh. So we have to identify the number of meshes. Next, step 2, we have to assign the mesh currents in clockwise direction. Each and every mesh current we have to represent. And third step we have to do is, by applying KVL first and Ohm's law next, we have to write mesh equations. After writing mesh equations, we have to solve those two equations to calculate each and every mesh current. Right. Now, so mesh analysis limitations also we discussed. This is about mesh analysis theoretical part. Use this theoretical part to solve, practice some problems. You can get complete idea about mesh analysis. Next, nodal analysis. The purpose is same like mesh analysis, means to find each and every branch current, voltage and power. Our main intention is to find the current only each and every branch. If you know the each branch current, the passive resistor values or passive element value will be specified in the nameplate details. We will calculate voltage. If we calculate voltage, power also we can calculate. Why? Because by using formula V into I. Now here nodal analysis. Same purpose, and the steps we required here are to identify the number of principal nodes. What is a principal node? There must be at least 3 or more than 3 elements has to exist. Step 2, we have to assign each and every principal node voltage with respect to ground. Ground means we have to assume any one principal node as a ground. With respect to that, we have to assume remaining principal nodes voltages. Mostly with respect to ground only. Take ground, you don't need to take in one particular node only. Take any one your wish. Right? By considering, we have to, next step 5, what we have to do? By applying KCL first and Ohm's law next, we have to write mesh equations. And above ground voltage mostly we have to assume 0. To understand this ground means, you assume suppose if any person height is measuring, what you are going to take difference as ground. If ground level changes, person height also changes. That's why ground should be reference, that voltage must be 0. See, in some examples I was given here how to know the node voltage. So what we discuss, node voltage, very important definition is here. So if you want to know any node voltage in the network, start from that node and go to reference or ground node by following KVL notations. Then easily you can calculate node voltage. If you want to know the branch voltage between one node to another node, means, so assume in the network one voltage source is there in one network, and voltage source magnitude you don't know, remaining all the branches voltages you know. Then to know that voltage, start from positive terminal and go to negative terminal. While calculating each and every branch voltage from positive terminal to negative terminal, not only loop, if you consider any loop, you can get the same answer. You have to get the same answer. That's the definition for branch voltage. See the statements I was given there here. Statement 1 here given as don't apply Ohm's law to current source. So because current source magnitude is given, you can't apply Ohm's law. And similarly, don't apply Ohm's law to voltage source. Apply Ohm's law if there is a resistor or passive element. If there is resistor or passive elements. And next, if between two meshes, if current source is existed, then we have to, then Ohm's law fails there while writing mesh equations. That time we have to use super mesh concept. Similarly, between two principal nodes, if there is only current source, also we can't apply Ohm's law. At that time also, by using super node concept, we have to solve the problems. Remember these two statements and practice problems. You can get some idea about these two statements. Very important statements these are. Next, open circuit and short circuit condition. Very important conditions those are, open circuit and short circuit conditions. See the characteristics in open circuit condition. In open circuit condition, current is 0, voltage will exist, resistance is infinity. To understand this, you take one simple network, voltage source connected with resistor. Now if you see in this network, if I ask how many elements are there, what you can say, only 2 elements are there. Why? Because only resistor we can't call it as a circuit element. If voltage existing, then we can say resistor is a circuit element. If I ask what is voltage across resistor, means no closed path is there from positive terminal to negative terminal of the voltage source. That's why current is 0. If current is 0, means voltage across inductor also 0. Voltage across resistor here, resistor is 0. That's why if I ask the voltage between here or resistor one end to another end, then it means I am asking the voltage between two nodes. Start from one node and go to another node, you can get the node voltage. Not only to this network, if the network is having hundreds of loops, you can take any loop, you can get the same answer. That's why here current is 0 means no current is flowing in the open circuit condition, hence current is equal to 0. See, voltage is nothing but what? If you know the voltage between two terminals, you have to start from one node and go to another node by following KVL notations. With that you can get source of open circuit voltage as in the example V is equal to 10 volts. So from this I is equal to what? V by R. 10 divided by I is equal to V by 10. I is equal to V by R, means our resistance 1 R is equal to V by I, means here voltage is existing, current is 0. So anything by 0 is nothing but infinity. That's why you can say in short circuit condition, open circuit condition, resistance is infinity. In short circuit condition characteristics, in short circuit condition, current magnitude will exist, voltage exist is 0, and the resistance exists also 0. To understand this, we take this example. See this example, I provided closed path to the resistor. Now if I ask now how many elements are there, we can say 2 elements, 10 volt voltage source 1 and 10 ohm resistor is there 1. If you corrected that, how much amount of current will flows? Now current will flows I is equal to V by R according to Ohm's law. V is 10 divided by resistance we connected is 20 ohms. So I 1 amp of current will flows. If 1 amp of current is flowing, the voltage across resistor is what now? 10 amps, 10 volts. We know how to specify the polarities. If current is entering into the any terminal of the passive element or resistor, we can consider that terminal as positive. Leaving is negative. Now how much amount of current is flowing through short circuit path? 1 amp means